Hi, this is Will, and we're going to take another look at this. This is the factory I/O, and it's called Pick and Place Basic. I've previously done one with the Control I/O where you don't need a PLC, and it's done in functional block diagrams type logic. And I wanted to do one with the Micrologix from Allen Bradley, and do it all in ladder logic. And when we did the one with Control I/O, the pick and place machine actually, and we'll show it a little bit, what happens is it has to make a number of similar steps, and we count the steps to know what we turn on and turn off. Now with this one, with all ladder logic, I think it's a little bit more complicated, and you can take a look at both of them and make up your mind. But this is going to be pure ladder logic. Now what we're going to do is, and we'll show the movements, but right now I have all the sensor tags turned on. I like that, so you can see what sensors are doing, and if they're not active, they're shown in white. They turn yellow when they're active. And if I dock all the tags, as usual for all our factory I/O, these emitter, where it drops in with the green arrow, is forced on, and so is the remover. So if I release them, and you can see that this is lit up, if I release it, that light goes out. So now it's not turned on. I'm going to do the same with the remover. And we're going to control both of these. Actually, for the emitter, we're going to have it on anytime we're in the, the logic is turned on through the start push button. And then we're going to control the remover out here. Now, a couple things, if you're not familiar with the factory I/O, this is switches between edit and run, and right now we're in the edit mode. When it's highlighted, you're in the run mode, and you can see all our sensors. If we're in the edit mode, it actually shows the beam for how far the sensor can actually sense items. So we have one going down, we have one, this is our item at entry, this is item at the exit conveyor. Now to control the remover, what I'm going to have to do is I'm going to need another sensor. And I'll make it just like this one, but I want to put it right at the end of the conveyor so I can turn on the remover circuit. So I can left click on it and then right click and say I want to duplicate it. And you can also use all these to move them around, but I want to duplicate it. And I kind of want to put it in the same position, but all the way at the end of the conveyor. So I think maybe right about there is correct. I got it just a little too far out. So let's try to move it back. Okay, that looks good. And now it's called diffuse sensor number 3. So what I'm going to do is I'm just going to click on it, and then it shows up here. I'm going to change that to exit shoot sensor. So when it gets past that sensor, I'm going to, and you can see the name change, but when an item passes there, I'm going to turn on the remover circuit for 1 second. So if we look at the basic way that this pick and place runs, I'm going to put in run mode. This button next to it is also the pause, and when I put in run, the edit palette goes away. Pause will stop it. This is the reset the simulation, so everything disappears, and this is the stopwatch that makes everything run in slow motion. So the first thing we want to do is we want to turn on the emitter, and to force it on, and this is the best thing about factory I/O, you can force all these actuators on to watch what happens, and then you can come up with how to write the program. So rather than do a lot of guesswork, you can just force these items on and see how it works, and then write the program based on that. So the first thing I'm going to do is force on the emitter. There's a part there. You get these little, I guess that's some type of lid, but they could be boxes, it could be a metal tote. And so for right now, I'm going to release it. We're going to just have our box there. And let me quick show that if you reset it, everything disappears. So if there was 5 items on the conveyor, they'd all disappear. So once again, we'll put a box down there. And here's the metal tote. We want to release that. Now, we're going to turn on the entry conveyor. And as it gets closer to this item at entry signal, the first thing I'm going to do is pause it. And then I'm going to put in slow motion so we can take a good look at what our signals are doing to figure out what that happens. And when it also gets at the item at entry, I'm going to turn off the entry conveyor. So when it gets to right about here, I'm going to pause it and put it in slow motion. So here's our entry conveyor, and I'm going to pause it, and you can see we're not at the sensor yet. And what we're doing is we have this entry conveyor, but we are going to go in slow motion. And as soon as we see this item at entry signal, this is the sensor, as soon as we see it light up or go active, we're going to halt the program again. And this will hopefully happen pretty quick, so let's take a look. Okay, there's the item at entry signal. And you can see that it went from white and now it's kind of yellowish color. So that means it's active. And you can see it lit up there. So now what we're going to do is we're going to turn off, we're going to release the entry conveyor. Now what we have to do, and I'm just going to walk through the pick and place steps, I'm not going to do the grab, which there is a signal, which grab is basically a vacuum suction that'll grab onto it and be capable of lifting it up. But as far as our pick and place, this is 2-axis motion, so we can move it in X, which is from the input conveyor towards the output, and Z, which is up and down. Now for both the move X and move Y, the move signal is the actuator, and then there's a moving signal, which is the sensor. And you can see this moving Z. So as soon as I turn on move Z, it's going to go downward. And we're going to see this signal go active since it is moving. Now, as soon as the moving signal turns off or goes inactive, that means this pick and place has reached its maximum travel in that direction. And as soon as it has reached there, we're going to want to go up immediately. Now, in the interim, and there's an item detected, and as soon as it's going down and an item is detected, we want to turn on the grab circuit. So I guess if we're in slow motion, maybe we can show that. And we'll be looking for this item detected signal going active. So first, I turn on the move Z, force it on, now I unpause it, and as soon as I see item detected, I'm going to pause it again. So item detected is on here. Now it is still moving in the Z direction, so it detects the item before it gets to the full travel limit. So at this point, I'm going to force on the grab signal, and I'm going to keep going in the Z direction. Now I'm waiting until this moving Z signal goes inactive, so it turns off. And this may happen really quickly here too. Okay, so there it turned off. So now, hopefully, we've grabbed the item, and now if I turn off by releasing the Z signal, now it's going to go upwards. And again, what we're going to be doing, and let me unpause it, is we're going to be waiting until this move signal goes off again. And there it went off. So now it's fully up. Now what we want to do is we want to turn on the move X, so we want it to go towards the output conveyor. So we're going to turn on the move X, going to unpause it, and we're going to wait till it goes the full limit of travel. And now I really don't have to pause it, but what I want to do, as soon as I see that signal go inactive, now I want to move it in the Z direction. So now it's going to go down again. Now I do want to wait, or I'm going to pause it when I see the moving Z go off. Okay, so again, now we're at the exit, and we've got both our Z and Y on. Now I can release the grab circuit. It's going to let it go. Now I want to release the Z so it goes back up. And got to unpause it. And when it gets all the way off and the moving Z signal turns off, now I'm going to go back home, which means I'm going to have to release the X axis. And you know, when this gets finished, we're back home. Now, because the emitter is going to be constantly on, there's going to be another part waiting for us to pick up. And there, it's finished its travel. So now it's back at the home position. Now, you know, when I let go of the item and start moving back up, I am going to have to turn the conveyor on and, you know, turn the remover on, but we're not going to show that right now. Now, one of the things when you go into the Micrologix, and for all the different types of PLCs that you have, they have tutorials, and this one is how to set up the Micrologix. Now, apparently, it only runs with either the 1100 or 1400 PLC, and it has to have an Ethernet connection. You know, these PLCs have both serial and Ethernet. It has to be Ethernet. And they also give a sample project if you want to take a look at it. Now, the 1100 is a fairly inexpensive PLCs as far as the cost of Allen Bradley PLCs go. And you can also get free software for it. Now, you have to look on the web, but, you know, it's, if you just say free software for Logix 500, software for Micrologix, you'll find a bunch of different places you can find that at. And, you know, if you have an older version of Micro 800, which are kind of odd to find, apparently it works with that. Now, the Logix 5000, that software is really expensive and kind of out of range for most people. You know, if you have it at work, you can maybe do that. But anyway, this shows you how to set up, and you know, it's just like setting up the regular PLC. You have to configure the drivers. You have to say it's got to be Ethernet. Got to give it a, you know, regular IP address. Now, and then you can go into this driver configuration and just select Micrologix, and then select the 1100. Now, here's the one thing that's unusual. So, when you select these devices, it will give you the pinouts. Now, these pinouts, you'll notice that it's file B3. Now, those are usually the internal memory bits. The outputs are the regular output files, but these are not the input files. So what we're going to do is we're going to leave the B3 :0 to be the inputs, and then we're going to start our internal bits at B3:1. So that way we kind of keep them separate. And that's pretty much it. That's about the only thing that you really need to do for the Micrologix, is just remember that we've got these B numbers. So let me minimize that. And so now let's go in to what we should do. We're going to leave the sensor tags on. I'm going to clear these dock tags. But if we go into File and we go into Drivers, now here we don't have any PLC selected. And you know, you have all the Allen Bradleys that you can use. There's some Modbus, and you know, if you have, there are some PLCs out there that you can use with this. And then they have the Siemens stuff. And what we want is Micrologix. Now, I happen to have, and you can also go into this configuration. We have to do two things. So right now, because normally the emitter and the remover are on by default, we need a couple more inputs over here. And because we've added that exit chute sensor, we need another input over here. So if you go into configuration, and I've already had mine set up for a 1400, and that's my IP address, but because we need more inputs and outputs, what we're going to do, I think, is we're going to make both of these 12. And we don't need 12 outputs, but we'll make them both the same. And if you just go back there, now we've got more inputs and more outputs. So now, because I've already put in the sensor that's exit chute, I can just drag it and drop it over here. And I'm going to do the same with my emitter. I'll make that 08 input, and I'll put the remover right after it. And that's that. Now, because we have this all connected up, we can connect to the PLC here. I'm not sure I have my PLC connected up or turned on right now, so it probably won't connect, but we'll get there in a second. Now, and right now we can reset everything. We can take it off of the time scale so we can run full speed. And what I'm going to do is I'm just going to show the code and talk through it. If you want to see the development of the full code, maybe you can look at that Control-IO version of this, because that is fairly detailed. But the first thing we want to take a look at, well, here's actually, and we are offline, so I can put it back online here. This is the code we're going to talk about, but the first thing I wanted to do is this is the RX Links, which is the communication software for it. Now this is free from Allen Bradley. So if we go into here and we say RSWho, it'll tell you everything that's out there that it can see connected to it. And again, we have this Ethernet. If I open this up, it'll say, oh yeah, that's this address, which is our IP, and it's at 1400. And this is the specific version of it. Now, all we need, we need this software to connect up to the PLC, but as far as operationally, that's all we need for this. So let's quickly try to walk through some of this. This first line is, this is the first pass or the first scan. And what we're going to do is we're going to set our counter to 0. I was playing around with it, so right now it was at 13. Now moving Z, we want to know when our signal goes from active to inactive. So this is a one-shot falling signal, so it's looking for the falling edge of it, and it's the same for both X and Y, or X and Z. And we want to monitor when it goes from high to low. Now these one-shots, they're going to put out a positive pulse. So even though it's looking for the falling transition, it's going to put out a rising pulse for one scan and one scan only. And that's kind of important for what we're trying to do. And down here we have our normal start push button, stop push button for our start process logic. We're going to use that start process to turn on our emitter and also to turn on the start lamp. Because, on the control panel over here, and maybe we should just show that for a second. What we've got is we've got these push buttons, and these are actually lit up. If you're in stop, it'll be lit up in kind of this red lamp, and when we're in start, it'll be lit up in the green. And here's our counter down here. Because we're not connected, it's just showing 0, but if we were to connect it right now, well, it'll still show 0, even though our logic says 13, because when we turn on and we go into the run mode, this first pass will go from 13 back to 0. So we get our start process, our emitter's always on. When our emitter's on, we want to have the entry conveyor turned on. And then we want to turn it off when we get to that item at entry sensor. Now when we get to that item at entry sensor, we're going to have our move Z direction for pickup. Now there's going to be two up and down motions. One is for pickup and one is for drop off. Now when we first see that sensor go high, we're going to say I want to move in the Z direction. And that's for the first item only. Every other time we're going to pick up an item, the item should be at that at that entry sensor. So what we have is for the first item, as soon as the item gets there, we're going to send out a pulse, and that's going to be the first item. And then every other one, we're going to have this endo cycle that is back. When we're back at the home position, we're just going to start anew with the motion of the pick and place. Now, the one thing about this ONS, and let me get back to some of our signals here. So if you go into bit, these one-shots, there's 3 types. There's this one-shot, which is ONS here, and that's what you use like 90–95% of the time, because usually you want to get a pulse when you're looking at an input. Now these other ones, there's one-shot rising, which I don't think there's any difference between the ONS right here and the one-shot rising, except both the one-shot rising and the one-shot falling are output commands. So they have the box around it. Now here, the regular ONS, you typically want to monitor an input signal. So you can put this in line and it'll put out a pulse so long as everything behind it is, active. So, we start the move Z pickup trigger whether we have this first item or this end of cycle. And this end of cycle also happens to be a one shot. So those are just one shots that trigger this. And we have this move X, and when we pick up the item and we have this moving Z complete, that's when we want to move from the input conveyor to the output. So we start it when the item picked up, and we move it back when the item has completed its drop-off. We'll skip across this, but then talk about this again. When we have moving for pickup, what we do is we just have this trigger, and it goes in there, and this is where you start the initial downward motion. And you start it, and as soon as it gets all the way down and it completes its motion, we unlatch it. Because again, this is a one scan trigger that's going to turn it on. When it goes all the way down, it's going to turn off, and it's going to move back up in the Z direction. Now, this moving Z for pickup or moving Z for drop off initiates the moving in the Z direction. So again, this will be just to have it down. Now the pickup done signal is when we're dropping off at the output conveyor. So when we have picked up the item and we say the item is picked up, and then the Z-axis has transitioned all the way back up, is we're going to see this completed signal. And here's where it gets a little, I don't know, the thing I think is more tricky about this is when we're going to pick up an item, we will grab it, and we grab it when we're moving in the Z direction. We detected the item, just like we showed earlier. And then when we drop it off is when we're going to ungrab it. But we pick up the item when we have it grabbed, and because we haven't fully transitioned all the way down, this pulse is going to go up, and that's when we're going to say item picked up. Now, back here for the moving in X, the item is picked up, but because it's looking for that one scan pulse again, when we say item picked up, this is the initial downward movement, and that's when we get this pulse here, and that's when the item is picked up. So when it goes all the way down, it's going to, when it gets this pulse, it says item is picked up, and then it's going to say, okay, that's pickup is done, and it's going to start going back upwards. And it's not until it gets fully upwards is when we get the second moving Z complete. And when it gets the moving Z complete, so it's all the way up at the highest point, that's when it's going to move from the input conveyor to the output conveyor. So the way you sequence these is you have to make sure, you would say, oh, well, wait a second, you want to pick it up and then you want to move it in X. But because this step, picking it up, has to take place before you want to move it in the X direction, this step must precede the one where you pick it up. If it was afterwards, as soon as you picked it up, it would try moving in the X direction, and you can't have that. So I think it's a little more complicated than using the integers, but you have to make sure everything is sequenced correctly. And the same is true with this dropped off, and maybe it makes a little more sense here. You have the drop off complete before the item is dropped off. And it's because they both use this moving Z completed signal. So you have to have this one active, so you're dropping off the item, because the item dropped off is also used in this one. So this will turn, the very next scan, this will be active, but this will not be active until the Z direction has gone all the way up to the vertical position. And then, if we go back to the move X signal, when the drop off is complete is when this signal goes inactive, and then that's when it goes back to the home position. Probably sounds a little bit more complicated, but what we have is, so then when we have the pickup is done, the drop off is complete, and then we've finished moving back home, and so this signal goes high, again for one scan, we're going to say that this one shot rising, and this output here is what we call the end of cycle, and that's going to start everything up again. Now, one of the things that I put in here, because when I was playing around with it, I didn't like the way initially we just had turn on the conveyor as soon as you drop off the item, but you're trying to drop off the item, you're trying to turn off the vacuum, and you're starting to start the conveyor all at the same time, and it just didn't look right. So we've got a little 0.4 of a second delay between the time when it drops off the item and when the conveyor starts, and that allows the vacuum to let go and to start to move back in the Z direction before the conveyor starts moving. And that's all that is. And when this timer is timed out for 0.4 of a second, then it starts the exit conveyor. It also puts a short little delay in the exit conveyor when the item is leaving, going down to the remover, and we'll take a look at that. But I kind of like the way it works. So it's got a little, and this is also a T off timer. So what happens is when it passes by the exit chute, the item passes by the exit chute, that's when the timer for the remover goes on. We have the timer set at 1 second, and then we just have the items processed. And then we move from our accumulator here into the counter of the factory I/O. And if we look at the drivers here, you can see that the actual counter is on the integer file 7.0. So that's where we're moving that. And then there's the reset push button, where all we're doing right now for this is just to say how many items we processed. So now if we go in here and we download it, and we can take a quick look at it running. And if we go into the factory I/O now, here's from our demonstration. So what we want to do is we want to reset it. We want to go into our files and drivers, and now what we want to do is connect. And when we connect, it should see the PLC, and there should be a green check mark or a dot or something that pops up over here when it connects up. And first time through might take a few seconds, but here it's saying it's okay. Now, it should look like this when we just see the stop lamp, because it is in the stop mode. And if we go here, we can take a look at this. It's got the counter at 0. Here you can see the light is on from the stop lamp. As soon as we hit start, that's going to turn off and the green light will turn on. And we can kind of watch it in its motions. And, the sequencing, I don't know if I explained it that well, but what we're going to do is we're going to switch those two commands and watch what happens when it does that. And, it doesn't look fatally flawed, but especially when we have those big metal totes, it doesn't act right. So you can see it's, going all the way down, item picked up, moves all the way across, all the way down, all the way back up. Now it's at the home position. And here was that little delay, is right here. It delays until the next item is on there, And you can see when the item passes by the exit chute, that's when the remover circuit turns on for 1 second and it removes the part. And here you can see our counter going up. So really quick, and you can see it runs pretty nicely. So I'm going to pause it, I'm going to reset it, and now I'm going to go back into the Logix. And here we're talking about this drop off complete and item dropped off, and they have to be in that order because you want this step to run, and then you have to wait until Z goes all the way back up before you turn on the next step. So if I just switch these two steps, so pickup done and item picked up, if I just move item picked up ahead of this, what's going to happen is, because this step depends on this step, and this step is dependent on the one shot from here. So as soon as this goes active, this line will be active, and what that does is that's going to turn on our X-axis a little prematurely. So let's try to download this and take a look at what happens. So if we go into the factory I/O, now what we're going to have to do here is, because we have a new program in here, if we go into the drivers, and I'm not sure why we get all these errors, but all you have to do is disconnect it and then reconnect it, and once again all we have is a stop light on, so we think we're okay. So if we go in here and we start it up now, so it seems like it's running fine. But we have these little quirkiness in there, and we don't want that. And also when you have the big metal tray, that causes a problem with that too. So we have the logic out of sorts, and we have the one command in front of the other command, so they're both happening simultaneously, and we don't want that to happen. So if we go offline, and we're just going to take this guy and move him ahead of the other one again. Yep. And that didn't do what I wanted to. So now it's pickup done is before the item picked up in the code. And that's the way we want it. Normally you would say, one rung follows the input from the other rung, but we do not want that. So let's download this. And sometimes, depending on how involved the codes are, these things can be kind of tricky to find out exactly what the problem is. But if we go back here, and here you can see, it causes a problem. But if we just reset it, and now here we've got 5 boxes on there at a time, and we'll go into File, Drivers, and again you can see now all the outputs are gummed up here. So, and anytime you change the code, you're going to get that. Now I've never really seen these red dots, and it gives this error that another node is the program owner. I'm not quite sure what that means. But anyway, if you just disconnect and reconnect it, everything should be fine. So we'll go up here, we'll let it run for a little bit, take it out of pause, and take a look at how it runs. And so with the steps all properly sequenced, it does do what we want it to. And that when they're out of sequence too, that's also particularly you can see it a lot with this metal tote, just because it's so large, and that the pick and place has to reach down inside of it to lift it up. And just take a quick look and there's our counter counting it, and it counts it when it's you know, it goes, I guess, past this chute, and you can see the remover circuit. Now another thing, and you kind of have to, because you can't be doing the pan, you can only do the pan in this movement, but one view that I really like, and sometimes it doesn't work too well when you're running the system, but after it drops this off and goes back home, let's just pause it for a second. Now if you go into drivers, oh, and I do have to keep it running since I don't have control in here, but if we go into drivers, and now, you know, you can see all the inputs and outputs, but it doesn't do you very much good because it's all dark. But if you have this little eyeball down here at the bottom, if you click on that eyeball, it kind of turns it like see-through version. So now you can see what's happening on your conveyor. You can take a look at your sensors. You can take a look at the PLC itself. And I like looking at, you know, these signals here to see if they're doing what I want them to do when I want them to do it. And I kind of like that view. So you can kind of, I think you can just click back out of the drivers to get the normal view. And, you know, we can see our counter's working. If we wanted to reset our counter, we can do that and try to get it to 0. And so let's look at that. Now, you know, I think that this coding is a little more difficult than the Control I/O, but I also wanted to try it with the Siemens version. And the Siemens version has, you know, a higher level of coding, but it should be a pretty neat and way to look at things. So we're going to take a look at that. That'll be a Siemens S1200, which that software is kind of pricey too, but maybe you can find some of that. So anyway, have fun with this. If you can find a PLC, try it with the PLC. You know, it's always good to learn Allen Bradley. At least in the US, that's the #1 variety of PLCs used. And you know, the Micrologix is a ton cheaper than you know, either the Compact-Logix or Control-Logix, and both the hardware and the software are, I think, kind of prohibitively expensive. You know, unless you're a business, individuals really can't afford that. So anyway,